Good day, teachers, students, and viewers. My name is Emmanuel. I'm a teacher teaching chemistry in Upper Academy High School, formerly known as Emmaus College, Jos Plateau State. This is a science teacher's game, and by the grace of God, I was able to carry out some chemistry experiments and projects with my SS1, SS2, and SS3 students this first time. And this include laboratory preparation of ester, electroplating of metals, the making of electrochemical cells, biogas, Redox titration, acid-base titration, influence test, separation techniques, and verification of law of conservation of mass, amongst others. In this science game, I consider it best to use my students for presentation rather than do it myself, and I strongly believe you will learn a lot from them. Please take your seats, and then thanks.
Good day everyone, my name is Adeyemi Kadiza, and with me is we are from Upper Academy Schools and we are in SS2. We are here to perform the experiment titled Redox Titration. Redox titration is a titration involving an oxidizing agent and reducing agent. Unlike acid-base titration, Redox titration does not require any indicator to show the endpoint. The titration agent behaves as a self-indicator. Some examples of oxidizing agents used during Redox titration include potassium tetraoxomagnate 7, potassium oxodichromate 6, and potassium trioxidate 5. Some examples of reducing agents used during redox titration include etadionic acid, sodium thiosulfate, and iron 2 chloride. And what are the procedures for redox titration? The same procedures for acid-base titration are applicable except that no indicator is required. And what are the apparatus used for redox titration? The same apparatus used for acid-base titration are also required here, except that we use our Bunsen burner, our measuring cylinder, and other apparatus include the burette, our funnel, the conical flask, our reducing agent, and our oxidizing agent. And now we are going to start our experiment, our practical. We are going to be making use of our Bn and our An. Our Bn here is our potassium permanganate, which serves as the oxidizing agent, and our An here is the oxalic acid, which serves as the reducing agent. And we also have our dilute sulfuric acid. Now I'll hand over to my classmates to continue the practical.
Let us start our practical now. The first step we do is to measure our reducing agent, which is our oxalic acid. Measure labeled An with our pipette into the conical flask. The pipette is 25 cm, the one we use in our school, and this is the mark point. Now we are transferring it into our second step is to now measure our dilute sulfuric acid with our measuring cylinder, and right now we are going to measure 10 ml of our dilute sulfuric acid. So these are 10 ml. Now we'll now transfer it to our conical flask, which contains our reducing agent. The next step is to fill our burette with our oxidizing agent, which is labeled B. But while we are doing that, we are supposed to keep this our solution away, and our potassium permanganate is supposed to reach the 0 meniscus level of the burette. So I can as well pour this into my beaker for easy pouring into the burette. So our solution exceeded the 0 meniscus level on our burette. So what I'll do now is to start reducing it to reach the 0 meniscus level exactly. So before I do, I have to remove my funnel so to not to affect our video. So now I release my burette, my tap. So this is now 0 mark point at 0 meniscus level. I'll hand over to my classmate to continue from here. Thank you.
Now we are going to heat our titration. The temperature should be between 60 to 70 degrees centigrade. The reason is to acquire an activation energy and to speed up the rate of reaction. If it hits above 60 degrees centigrade, oxalic acid will begin to decompose, and if the temperature is too low, that is below 55 degrees centigrade, the interaction between the oxalic acid and the potassium permanganate will move too slowly. And now we'll on our Bunsen burner, but before that we have to drop our conical flask and our wire gauge, and this is our lighter to switch. And now we are going to place our wire gauge to heat up our titrant. And this is our thermometer. We use it to check the temperature of our solution. Now we'll titrate our solution while hot. While titrating, remember not to look at the burette, and the purple color of the potassium permanganate will be reducing it, and the endpoint will be pink. As you can see, we've reached the endpoint of the titration. As you can see, we've reached the endpoint, and the endpoint is pink. After titrating, now our reading is at 22, taken at meniscus level. After titrating, we write down our values. Remember, we didn't use any indicator, so it's not stated here. We only write down the volume of ppl used, which is 25 centimeter cube. We write down our burette reading, our final reading, initial reading, and the volume of KMNO4 used, which is all written in centimeter cube. Our initial reading is 0.00. Our final reading is 22.00. We find the difference, which is 22.00. Now we repeat the same procedure for our first, second, and third titer, which will be done in our group practicals. Thank you. Good day everyone, we are here once again to continue our practical as we said the other day. At the end of this, I'm going to show you my result for the first, second, and third title of the redox titration. Thank you.
Where's Khadija? This one.
As you can see, the oxalic acid is neutralizing the potassium permanganate, and we've almost reached the endpoint. Okay, here is the endpoint of our redox titration, and we are going to proceed with our first, second, and third title. This is my rough title. This is dilute sulfuric acid. I'm measuring it to tell me to put into my oxalic acid. Since oxalic acid is a weak acid, it will provide a completely strong acid medium. So dilute sulfuric acid is added in order to provide a strong medium. Like I said earlier, in redox titration we don't use any indicator, so the volume of ppl used is mentioned here, and my burette reading, final reading, initial reading, and volume of potassium permanganate used are all in centimeter cube. And remember, all your values are meant to be in 2 decimal places. The average volume of potassium permanganate that neutralized oxalic acid is this, and the same For the other calculations, the same calculation for acid-base titration is also applied here. Thank you.